Hello everyone, myself Sindhuja. I'm from branch EC and I'm studying in Srinivasa Ramanujan Institute of Technology, Anantapur. And today my presentation is on the subject of probability and complex variables on topic Cauchy's theorem and the subject code of probability and complex variables 23 mat 06, and my roll number is 23401A04A7. And let us know what is meant by Cauchy's theorem and their formulas. In the Cauchy's theorem, it if f of z is an analytic function and f dash of z is continuous at each point within and on a closed curve C, then we say that integral f of z dz is equals to 0. And once again I repeat the formula and definition of the Cauchy's theorem. If f of z is an analytic function and f dash of z is continuous at each point within and on a closed curve, then integral f of z dz is equals to 0. And let us see about what is mean by Cauchy's integral formula. If f of z is analytic within and on a closed curve C, and if a is any point within C, then integral curve f of z by z minus a dz is equals to 2 pi f of a. Once again I repeat that if f of z is analytic within and on a closed curve C, and if a is any point within C, then integral f of z divided by z minus a dz is equals to 2 pi f of a. This is known as what? Cauchy's integral formula. Let us see example problem. Show that to calculate integral C dz by z square plus 4 whole square, where C is modulus of z minus I is equals to 2. Let us see the solution for above question. Given that integral dz by z square plus 4 whole square, we take it as equation 1, and also given that C is equals to mod of z minus I is equals to 2. By Cauchy's generalized integral, we know the formula of Cauchy's generalized integral. Integral f of z by z minus a whole power n plus 1 dz is equals to 2 pi I by ni into f power n into a. Let us take it as equation 2. We can observe in the beside graph the x and y axis, and on the y axis above x axis I 2i, and below x axis we represent minus I and negative part, and z square plus 4 is equals to 0, and z square plus 4 u's rise to z is equals to plus or minus 2i. Z is equals to 2i, u's rise to 2i minus modulus of 2i minus I is equals to 2. Modulus of 2i minus I. Therefore, modulus of I is equals to 2, and 1 is less than 2. It is the part of inside the circle, whereas we saw in before page the diagram z is equals to minus 2i. Modulus of minus 2i minus I equals to 2, whereas minus 2i minus I becomes minus 3i. So modulus of 3i is equals to 2. Modulus of minus 3i becomes root 9, that is equals to 2. 3 is greater than 2. It represents the outside of the circle as we saw seen in the diagram. And z square plus 4 is equals to z plus 2i into z minus 2i, and 1 by z square plus 4 is equals to 1 by z plus 2i and into z minus 2i. 1 by z plus 2i divided by z minus 2i. integral dz by z square plus 4 whole square is equals to integral 1 by z plus 2i whole square by z minus 2i whole square into dz. 2 pi I divided by 1 by f of 2 pi I divided by 1 f dash of 2i. F of z is equals to 1 by z plus 2i whole square. F dash of z is equals to minus 2 by z plus 2i whole cube. We know that the formula x power minus n is equals to nx power minus n minus 1. A is equals to 2i and n is equals to 1. Whereas f dash of 2i is equals to minus 2 by 4i whole cube is equals to minus 2 by 64i square into I. 1 by 32i. Integral dz z square plus 4 whole square is equals to 2 pi I into 1 by 32i is equals to we got that pi by 16, hence proved. Therefore, the given problem is verified through Cauchy's integral formula. Thank you.